Alright, so let's continue with the annuity equaling a future value. Alright, so let's say an example. Assuming that a 10% interest rate after 4 years and you receive 4,641. Alright, you have 10% interest rate and you have 4 years, and you know how much you would be accumulating end of the fourth year, which is 4,641. Alright, so now the question is asking how much annuity is. Alright, so as you can see here, your future value annuity given, future value interest factor. Alright, future value annuity interest factor you can calculate based on two information, which is the interest rate and also the n, which is 4. Alright, so this interest factor you can use calculator, use the formula, or you can use the PV table to find out, right? So you have 4,641, and these figures you can calculate through the PV table. Then you can calculate the annuity, which is future value annuity divide by future value annuity interest factor, which will give you the value of annuity. How much you need to invest for the next 4 years in order to get 4,641. So the answer is would be 1,000. Alright, so from this I can tell you that when it comes to time value of money, there is only 5 items that you will compute. Alright, that you will calculate. So the first one is you either want to calculate the present value or future value, present value annuity, future value annuity, or the last thing we just learned, which is annuity. Alright, so any question they will be asking any item, one of the item from the from the five things here. Alright, future value, present value, future value, present value, and also annuity. Right. Alright, so this is how it's done. Your future value annuity is 4,641 and your interest factor is 4.641. Alright, from your table, or you can use the formula given to calculate. At the end, you'll be getting 1,000. So determining what size annuity can be equated to given amount. Right, so this shows like the similar with the previous example. Alright, the difference here is instead of we are using future value annuity, now we are using present value annuity. Alright, so when a present value annuity given and I given, you can able to calculate the annuity. Alright, so assuming n equals to 4, I equals 6%, present value annuity is 10,000. The only missing thing is your present value annuity interest factor. So 10,000 divided by 3.465, you'll be getting 2,886, right? Which means every year you will be withdrawing 2,886, right? In the beginning, you deposited 10,000, alright? With 6% interest, you'll be end up getting, you will be having in the bank 10,600, but you will be withdrawing 2,886. Alright, so that is your annuity. Remaining would be 7,714. That 7,714 will give you interest another 6%. Then you withdraw again 2,886. You'll end up having 5,290. So in year 3, again interest, you withdraw this amount, you have ending balance of 2,722.29. Again, on the fourth year, you get interest in the remaining balance, which equals to the amount you're withdrawing. Therefore, at the end of the year, you have zero balance. Right? So if you withdraw exactly this amount, you will end up having zero balance. Alright. So in the previous example, we find out how much you are investing every year, 1000 for the next 4 years. Here we are calculating how much you're withdrawing. Alright. Yeah, that's because this is the present value annuity, which means you have already deposited 10,000. Alright. So let's find out what the necessary repayment on loan. Alright, so let's assume the company has n equals to 20, I interest is 8%, the present value annuity is 40,000. So the annuity would be 40,000 divided by the interest factor 9818. So your annuity would be 4074. Alright, here the question is you have taken 40,000 loan, then you need to find out how much you have to repay in order to settle your loan. Alright, so for the next, let's say 20 years, alright, you have to pay 4074 in order to settle your loan. Alright, so your total payment is 4074 for next 20 years, which equals to 81,480. Right, for the next 20 years you're paying 4074, which equals to 81,480. Your repayment of principal would be 40,000, right? Your repayment of loan, the 4074, includes the payment of principal plus the interest amount. All right, so just you can think the example of buying a house or buying a car. All right, let's say you're monthly paying this amount of money that includes interest and principal. Let's say you end up paying 81,480. All right, how much you have taken? Your loan was 40,000. Therefore, what is the interest? The interest alone is 41,480. It's actually higher than the principal itself. Alright, that's what usually happens. When you pay back a car, when you pay back the housing loan, you end up paying more than your principal. Sometimes could be double, sometimes can be 3 times the value of your principal, right? So this is how it's the process behind, right? You see your beginning balance of 4,000, you're paying 4,074. The interest charge, all right, would be 3,200 for the loan you have taken. That's the remaining balance, right? Then repayment on principal is 874, which means out of the 4,074, in the beginning you're paying 3,200 on interest and only 874 on the principal. Alright, then you have remaining 39,126. So if you can see this pattern here, in the beginning you are paying most of your annual payment is actually on the interest. Alright, so you see 3,200 is interest, only 874 on the principal. Alright, that's why if you settle your loan earlier, you still need to pay big sum of principal, because in the beginning of the loan period you are only paying interest amount, right? Most mostly on the interest amount. So your principal will always be there, always be higher in the beginning period. You see, 40,000 after paying 4,000, your principal is your principal is just reduced by 800 plus, right? So remember, in the beginning part, you are paying more interest. Therefore, your principal will be high, right? Of course, on the 20th year, when you come down here on the 20th year, you will end up paying the full, the interest, principal, and your ND balance will be zero. All right. So this is just the formula that you can remember, right? So all of it here, that includes the interest factor or interest factor annuity. All right, so let's calculate the yield. So let's look at the example here. To calculate the yield on an investment producing 1,464 after 4 years, having a present value of 1,000. Alright, in a question, you need to know, if let's say you're doing a present value questions, you need to know the present value, you need to know the N, you need to know the I, and you need to know the future value as well, right? So here, in this question, the investment producing 1,464, alright, you are investing in the result, you're getting 1,464, that means they're talking about the future value, and n equals to 4, and the present value equals to 1000, which means present value given, future value given, n is given. So what was the remaining item? Is the I, it's the interest. So you can calculate the interest based on the formula that you've learned, right? So how you do it? Present value equals to future value times present value interest factor. Alright, so present value is 1000, future value is 1464, therefore your present value interest factor is 0.683. Alright, so class, this is not the final answer because this is the interest factor. Interest factor includes N and I, right? So you have this number 0.683, which if you still remember, interest factor, you usually find it from the PV table, right? So if we go back to the PV table, all right, so you take out the present value table, right? And let's look at the numbers that you already know, which is n equals to 4, all right? So you know the periods is 4, then you need to find the interest, right? So how do you find the interest? You need to find this number 0.683. Where is it in the entire rows of the entire row of number 4? All right, you see, is it in the first person, second person, third, fourth? It is on the 10th percentile, right? 0.683. So n equals to 4, and you already know what is the interest factor, therefore the one exactly intercepts is the 10%. So you know the interest is 10%. Alright, so that's how you can calculate the yield or interest. Alright, so use the table to calculate. Alright, so of course interpolation methods can be used. Interpolation means more of trial and error, right? Difference between future value interest factor value at the lowest interest rate and designated present value interest factor, present value interest factor. Alright, so here just an there are other way of calculating by using interpolation method because it's a trial and error. All right, but what we're going to be using mostly is calculating time value of money using the PV table. All right, you don't need to do a trial error. It might be time consuming, and sometimes you have a difficulties to find the matching answer. All right, so let's do a present value and annuity. All right, you need to calculate the yield on an investment that gives you 10,000, producing 1,400 per annum for 10 years. All right, so this is a annuity question. All right, so investing once 10,000, but in return you're getting 1,490 per annum for 10 years. All right, so that 1,490 years repeating every year for the next 10 years, and you want to know how much is the yield. All right, so you will be doing the same thing. Present value annuity equals to annuity times present value annuity interest factor. So present value annuity would be 10,000. Annuity is 1,490. Therefore, your present value annuity interest factor is 6.712. So is this the final answer? All right, it's not right. So this is just the annuity interest factor. So what do you have to do? You have to open present value annuity table. All right, under that, look at the row number 10. All right, n equals to 10, and then find for this number 6.712. All right, wherever the amount is, you look at the exact column. The exact column shows the I or the interest figure. Right, so that is the interest rate for this question. So that is how it is done. Alright, so these are the special consideration in time value analysis. Alright, because all this while we have been just doing an example based on annual basis. Alright, every year. But there is always chances of having more than once a year. Alright, more than once a year means in a year your interest can be compounded twice. It could be compounded quarterly. Alright, quarterly means in a year 4 times, or even monthly. Alright, so what you have to change is annual means n equals to 1. Semi-annual means n equals to 2, because you're compounding twice a year, 6 months, 6 months. And the other one is quarterly, so you are compounding every 3 months, so n equals to 4. Monthly is 12 months, right? So you have to not only change the n, you have to change the I as well, right? Because since we're using annual interest rate, if let's say a question give you I equals to 10%, right? Annual means just 10%. But if you're semi-annual, you cannot use the same 10%. You have to divide the 10% by 2. Alright, if it's a semi-annual question. 5% in the first 6 months, another 5% for the second 6 months. Alright, if it's quarterly means 10 divided by 4. Alright, so that is how it's done. So remember, when the time value of money, when the question says semi-annual, quarterly, monthly, then you have to change n and also I. Alright, so let's do an example here. Determine the future value of 1,000. Investment up to 5 years of 8% annual interest, compounded semi-annually. Alright, so now we have a question with a different term, which is semi-annual. Semi-annual means 6 months. Alright, every 6 months it's a compounding. So what I said, you have to change two things. One is n, another one is I. Alright, so n becomes 5 times 2 equals to 10 years your I equals to 8% divided by 2, therefore 4%, right? So present value is 1000, future value interest factor, because the question already tell you that determine the future value. So you take the future value table, all right, look under n equals to 10, row n equals to 10, column 4%. So you'll be getting 1480. That is your expected future value. All right. Case 2, determine the present value of 20 quarterly payments of 2000 each to be received over the next 5 years, where I equals to 8% per annum. All right. So they said 20 quarterly payments of 2000 each. All right. So they are paying 2000. All right. 20 quarterly payments for the next 5 years. All right. So for the next 5 years, since it's quarterly, all right, in a year 4 times. So 4 times 5 is equals to 20. All right. In this question, of course, they say 20 quarterly payments, but sometimes they don't say. They say 2000 each to be received over the next 5 years, where I is 8% per annum, and the compounding is quarterly. All right. If they say that, then you know in a year 4 times 5 years equals to 20, and then your I is annual rate. Therefore, you need to change your annual into quarterly, which is 8% divided by 4, so equals to 2%. All right, so class, make an amendment here. It is supposed to be 2%. All right, n equals to 20, I equals to 2%. 8 divided by 4. All right, so your annuity times present value annuity interest factor. All right, as n is 20, I is 2%. All right, so this value, present value annuity interest factor, you can calculate by looking at your present value annuity table, and the annuity is 2000. So 2000 times 16.351, your present value annuity is equals to 32,720. All right, so here supposed to be just 2000 times 16.351. So the answer is 32,702. Right, so that would be the example. So with that, we are completing the time value of money chapter. All right, thank you.